The National Electrical Code specifies the maximum number of bends allowed in a 100-foot straight length of electrical metallic tubing, or EMT, based on the conduit size. For 1/2-inch EMT, the maximum number of bends is 32. For 3/4-inch EMT, the maximum number of bends is 28. For 1-inch EMT, the maximum number of bends is 24. For 1 1/4-inch EMT, the maximum number of bends is 20. For 1 1/2-inch EMT, the maximum number of bends is 16. For 2-inch EMT, the maximum number of bends is 12. For 2 1/2-inch EMT, the maximum number of bends is 8. For 3-inch EMT, the maximum number of bends is 6. For 3 1/2-inch EMT, the maximum number of bends is 5. And finally, for 4-inch EMT, the maximum number of bends is 4. The NEC also specifies that the sum of the angles of all bends in a given section of conduit shall not exceed 360 degrees, including the angles of any bends made to facilitate pulling of conductors. To calculate the maximum number of bends within the 360-degree limit, use the following formula: maximum bends equals 360 divided by the angle of each bend. For example, for 1/2-inch EMT, the NEC allows a maximum of 32 bends. If each bend is 30 degrees, the formula would be maximum bends equals 360 divided by 30, which equals 12. Therefore, in 100 feet of 1/2-inch EMT, you can make a maximum of 12 bends with each bend angle not exceeding 30 degrees. Let's delve further into the specifics of conduit bending, focusing on the regulations set forth by the National Electrical Code and the practical implications for electrical installations. The limitations on the number of bends and the total bend angle are in place to ensure that conductors can be easily pulled through the conduit without damage, reducing the risk of installation failure and potential electrical hazards. When planning an electrical installation, it is essential to consider the route of the conduit and minimize the number of bends wherever possible. Straight runs are always preferable, but when bends are necessary, they should be as gentle as possible. Using a larger radius bender can help to reduce the angle of each bend, allowing for more bends within the 360-degree limit. Understanding the NEC requirements for conduit bending is crucial for ensuring a safe and compliant electrical installation. The code provides specific guidelines for the maximum number of bends allowed in a 100-foot section of conduit, as well as the maximum total bend angle. These requirements are designed to prevent damage to conductors during installation and to ensure that they can be easily replaced or repaired in the future. In addition to the NEC requirements, there are also practical considerations to keep in mind when bending conduit. For example, it is important to use the correct size bender for the conduit being used. Using the wrong size bender can damage the conduit or result in bends that are not uniform. It is also important to lubricate the conduit before bending to reduce friction and prevent kinking. There are different types of conduit benders available, each designed for specific types of conduit and bending applications. Hand benders are commonly used for smaller diameter conduit, while hydraulic benders are used for larger diameter conduit and more complex bending operations. When selecting a conduit bender, it is important to consider the size and type of conduit being used, as well as the complexity of the bending job. Proper technique is also essential for achieving accurate and consistent bends. This includes using the correct bending sequence, applying even pressure, and monitoring the bend angle throughout the process. Practice and experience are key to mastering the art of conduit bending. Let's explore some additional considerations for conduit installations, including the selection of appropriate fittings and supports. Fittings are used to connect sections of conduit together, as well as to connect conduit to electrical boxes and other equipment. There are various types of fittings available, each designed for specific applications. Compression fittings are commonly used for EMT conduit, while threaded fittings are used for rigid metal conduit. It is important to select fittings that are compatible with the type of conduit being used and that are approved for the intended application. Supports are used to secure conduit to walls, ceilings, and other structures. The NEC specifies the maximum spacing between conduit supports, which varies depending on the size and type of conduit. Proper support is essential for preventing the conduit from sagging or becoming damaged. There are different types of supports available, including straps, clamps, and hangers. The type of support used will depend on the specific installation requirement. When installing conduit, it is important to follow all applicable codes and standards. This includes ensuring that the conduit is properly grounded, that all connections are tight and secure, and that the installation is inspected and approved by a qualified electrical inspector. A well-designed and properly installed conduit system is essential for providing a safe and reliable electrical distribution system. In addition to the practical aspects of conduit bending, it is also important to understand the theoretical principles behind the process. Conduit bending involves applying force to the conduit to deform it into the desired shape. The amount of force required will depend on the size and type of conduit, as well as the bend radius. Understanding the relationship between force, bend radius, and material properties is essential for achieving accurate and consistent bends. There are various software tools available that can help to calculate the required bending parameters for different conduit sizes and bend angles. These tools can be particularly useful for complex bending operations. Furthermore, consider the implications of different bending techniques on the structural integrity of the conduit. Overbending or using excessive force can weaken the conduit and make it more susceptible to damage. It is important to use the correct bending techniques and to avoid exceeding the maximum bending radius specified by the manufacturer. Regular inspection and maintenance of conduit systems are essential for ensuring their long-term reliability. This includes checking for signs of corrosion, damage, or loose connections. Any damaged or deteriorated conduit should be repaired or replaced promptly to prevent electrical hazards. In summary, conduit bending is a critical skill for electricians and electrical contractors. A thorough understanding of the NEC requirements, proper bending techniques, and the selection of appropriate fittings and supports are essential for ensuring a safe and compliant electrical installation. Continuous learning and professional development are important for staying up to date with the latest codes and standards, as well as for improving bending skills and techniques. Now, let's discuss some common challenges encountered during conduit bending and how to address them effectively. One common challenge is kinking, which occurs when the conduit collapses or deforms during the bending process. Kinking can be caused by using the wrong size bender, applying excessive force, or failing to lubricate the conduit properly. To prevent kinking, it is important to use the correct bending techniques and to ensure that the conduit is properly supported during the bending process. Another challenge is overhauling, which occurs when the conduit becomes distorted and loses its round shape. Overhauling can be caused by using a worn or damaged bender, or by applying uneven pressure during the bending process. To prevent overhauling, it is important to use a well-maintained bender and to apply even pressure throughout the bending process. Springback is another common challenge, which refers to the tendency of the conduit to return to its original shape after being bent. Springback can be caused by the elasticity of the conduit material. To compensate for springback, it is necessary to overbend the conduit slightly. The amount of overbending required will depend on the type of conduit and the bend angle. Accurate measurement and layout are crucial for achieving precise bends. Before bending any conduit, it is essential to carefully measure the required bend angles and offsets. Using a level, protractor, and other measuring tools can help to ensure accuracy. It is also important to clearly mark the conduit to indicate the location of the bends. Proper communication and coordination are also essential for complex conduit installations. This includes working closely with other trades such as plumbers and HVAC technicians to ensure that the conduit system is properly integrated with other building systems. Effective communication can help to prevent conflicts and delays. Furthermore, consider the environmental conditions in which the conduit will be installed. In corrosive environments, it is important to use conduit and fittings that are resistant to corrosion. This may include using galvanized steel conduit, stainless steel conduit, or PVC conduit. In extreme temperatures, it is important to use conduit that is rated for the specific temperature range. Documenting the conduit installation is also important for future reference. This includes creating a detailed drawing of the conduit system as well as recording the location of all bends and fittings. Accurate documentation can be helpful for troubleshooting and maintenance purposes. In addition to the technical aspects of conduit bending, it is also important to consider safety. Always wear appropriate personal protective equipment, such as safety glasses and gloves, when bending conduit. Be aware of the potential hazards associated with the bending equipment, and follow all safety precautions. Disconnect power to any electrical circuits before working on conduit systems. Continuous learning and staying informed about the latest advancements in conduit bending technology are essential for maintaining professional competence. This includes attending training courses, reading industry publications, and participating in professional organizations. By continuously improving your skills and knowledge, you can provide your clients with the highest quality conduit installations. Finally, let's discuss the importance of ethical conduct and professionalism in the electrical industry. Always treat your clients with respect and integrity, and provide them with honest and reliable service. Adhere to all applicable codes and standards, and never compromise safety for the sake of expediency. By upholding the highest ethical standards, you can build a reputation for excellence and earn the trust of your clients. In conclusion, mastering the art of conduit bending requires a combination of technical knowledge, practical skills, and a commitment to safety and professionalism. By following the guidelines outlined in this discussion, you can become a proficient conduit bender and contribute to the success of your electrical projects. Remember, continuous learning and a dedication to excellence are the keys to success in the electrical industry.